Hello everyone. Good afternoon. My name is Divya Sharma and I'm a database specialist SA at Amazon Web Services. And today we'll be discussing with queries, also called as common table expressions, and their materialization. Right? We'll cover a bit about what are these, what are the basics, what are the advantages of using them, and what is the impact of materialization on these, and if you should use them or not, right? But why are we discussing this, right? That is more important to me. Like, why, out of all the topics, why are we discussing common table expressions? Because I work as a database specialist and my job is to help customers migrate their workloads to AWS and also to optimize how they use RDS and Postgres on RDS and Aurora on AWS. So I get a lot of customer questions about migrations and also about how do we do this, why is this failing, what is happening, a lot of what Robert also explained about auto vacuum, it's very common. But this was an uncommon one, which I had heard for the first time, about common table expressions. And then the question was, the customer migrated from Aurora Postgres version 10 to 13 and added the keyword materialized in front of their CTEs, right? And their question was, why has the performance degraded? Is it because of the new version? Why has it degraded in the new version? You know, it should be better. And why, after adding that keyword, it has degraded? So they did two operations at once. They changed the version and they also added that keyword, right? Now, for me to understand what actually impacted the performance, I had to dive deep into two different things, right? One, okay, is it really the version or is it just that keyword? So let's understand this a bit more, right? What are CTEs? Common table expressions is a way of breaking down complex queries into auxiliary statements which can be used in a main statement, right? So the syntax goes something like this. You have the with clause, it starts with the with, then it's the name of the CTE, right? Just like you have name for the functions. Then you define what you want to compute in the, as an auxiliary statement. And then you use the result in the statement itself, what was computed with the CTE, right? Both the CTE and the statement can be create, insert, select, update, delete, anything, right? So they could be anything, both of them. And you can think of it as the result of the CTE gets created as a temporary table and it is valid for the whole duration of the query. Right? So it works like that. Now, this is a very simple example taken from the Postgres documentation of common table expressions. And as you see, there are two auxiliary statements here, which is the regional sales and the top regions. And the third one is the main select, main statement. So the first one is again, the result of the first one is used by the second one, and these two are CTEs, and this is the last final select. Now, this is taken from the Postgres documentation, as I said, but it just shows you a simple way of, a more organized way of writing a query, right? What is the difference? Like, why would I do something like this? So I'll explain that in a minute, but before that, what settings impact common table expressions? Workmem, it does impact CTEs because, as you would know, general working of workmem is if you're doing any sort, join, or any operations like that, or if you're materializing something, it is in the memory, and if memory is not enough, it will spill to disk. So if I have enough workmem, it's great. It won't spill. So you will see results, different results if you increase the workmem. The second one is enable material, which is a parameter which basically tells the planner if it should materialize or not. The thing is, this parameter is not explicitly related to common table expressions. It just basically tells the planner if it can do that or not for any general query, right? So that's what it means. So yeah, it has no specific impact to only CTEs. The third one, planning cost parameters, which is sequential page cost, random page cost. Again, the same way. It doesn't have an explicit impact only on the CTEs. It works the same way it would in any other queries as well. So these are some of the things which could impact. Now, what are the advantages of using common table expressions? Like, why would I want to use them, right? So this is a sample table. This is the same table which the CTE was from. And this is again taken from the Postgres documentation. It's a very simple table with 4 columns, right? Some sales data of products, right? So this stores that. And this is the result of that query which I showed you in the beginning. So basically, it shows the sales of the top 10 products of the top regions, right? Of the basically which is contributing to the maximum sales. The region 2 is out of this result because it didn't match the where clause of the statement, right? But it actually shows, this report is only to show you what is the power of CTEs, what you could do. You could generate reports like this, right? So this is that CTE again, which I showed you earlier. And what it does is, the first one is calculating the regions. The second one is using the result of the first one to calculate the sales. And the third one then is using the temporary result created by the first two to generate the report, generate the aggregation report, right? It adds readability because this CTE can be written as a subquery as well, which I will show you now. But if you are asked to change a reporting, a reporting query like this, it can take much longer if it's a long, if it's a longer line of SQL. So it could take you more time. But in this case, because it's much simpler to read and understand, it would be easier for you to modify this. So this is the subquery example of the same CTE. Now, as I said, because this is a simpler example, it seems simple that, okay, this is also easy to change, But the thing is, it could be much more difficult for long lines of code. Then comes reusability. So CTEs by design are reusable. So you are calculating, as I gave in this example itself, you are calculating the result of regional sales once. And once that result is calculated or evaluated, you are using that, you can use that multiple times. And it is only calculated once. So it's computed once, you can use it more times. The advantage of this is, if it's a complex calculation, it is computed once and you don't need to do the expensive calculation again and again. But if there is a caveat to this as well, if this happens, if it is calculated beforehand, you cannot pass the conditions from the primary select statement down to the CTE level. So you cannot pass the conditions, if there are any conditions here explicitly, down to any level of the CTE. That is not possible. So the reusability, right? That's what we were discussing. Then comes another feature, which is called recursion. And it basically allows you to, so with CTEs, you can do things which are not possible with general SQL standards, and which is recursion. So by adding the recursive keyword after the with clause, you can make CTEs, you can have recursive recursive possibilities. And how? By just adding that keyword. So you add that keyword, you have a non-recursive part and you have a recursive part, right? So the non-recursive part in this case is just simple select one. And the recursive part, in the recursive part, the CT is calling itself. So if you see the name of the CT is that, and it is calling itself in the in the recursive part, right? And that's how it is obtaining recursion, right? Then we union all, right? The difference is that union will not produce any duplicate rows, but union all would. So in this case, it doesn't matter because I started from n plus 1, right? But yeah, that's basically how a basic recursion works, and this is just counting 1 to 5. But yeah, I will get into a better example of why would you need recursion if you're using CTs. But yeah, this is simply to understand how it works. But you have to be very conscious of one thing, that when you're using recursion, like any other recursion, even here, you need something to terminate it, or you need something to stop it, because there is no clear indication. Otherwise, if you're stopping it or not, you have to look very closely into the plan. So when I was running that same query without limits, it wasn't terminated in the first one, and it was running forever. I have that as well. But when I added a limit or I added a where clause, you will see it in the plan, of course, as a filter for the where clause and as a limit in the query plan, right? This is there. But if you don't do it, there's no explicit indication in the otherwise that, okay, I have not, specified any limits. And it is important, because if you don't specify limits, it can actually run forever, consuming your resources and your bandwidth. So yeah, you have to be careful of that. So this is a better example of recursion and a more realistic or real life example which you could use. So recursion is very useful in traversing tree-like structures, right? And this is a table which I have, which stores employee information, and it stores information about employees and their manager IDs as well. Now, I want to write a CT which will give me all the subordinates from one particular manager, right? That's what I want to achieve. So I do a recursive CTE here, where there is a non-recursive part and a recursive part, which we just understood from a simpler example. And here in my non-recursive part, I pick an employee with a specific ID, right? Because that's where I want to search from, okay? So I pick just one single person from where I want everybody, and where ID equal to 1, that's the clause. And then in the recursive part, I join the employee table with the CTE managers on the ID, on the employee ID, right? On the manager ID, sorry. And that's how it is able to traverse the tree and give me the result, right? So it is very helpful in these kind of reports where you can, in tree traversals basically, right? And I also put a column with level because I also wanted to see the level. So whatever you want to do, you can just add there as a, as another thing. But I wanted to see the level as well. So I just added another column as a level. So that's something you could do as well. In Postgres 14, there was a feature which was added, which is the depth clause. So if you are doing such tree traversal reports or some reports like this, you can add the depth clause there, which will actually help you, which will actually generate a computed column to visualize the result as a tree. So another application of this could be maybe, any travel, any companies related to travel which need to see these tree-like structures, right? Any routes or maps. So now that we have discussed some of the features and how is it helpful, what are the advantages. I'll just take a sip of water. And we will discuss what is materialized, right? So I've discussed basic CTs, I've discussed how the other things work, I've discussed quite a few advantages also. But now I want to explain what does this keyword mean, and when was this launched and what difference has it made, right? So materializing CTs basically means you start running the query, it goes to the planner, right? Planner, executor, and everything. So it goes to the planner. The planner is planning the query, right? Now, how is it planning it? If it is materialized, it means the result of the CT will be computed and will be stored in a temporary table, right? And this is how it will plan it. So the result of the CT will be computed, will be stored as a temporary table, and will be used by the primary statement as and when needed, as many times, right? Now, this, again, what is the problem with this? This has been the default behavior before version 12. And why? So, basically the thing is, if this is happening, it's not like it's generating different plans, like a different one for a CT and then a different one for the primary statement. No, it is only one plan. But what we mean by this is the CT it's stored as a temporary table, and it is also evaluated before the primary statement. And why is it different? Because we are not planning these two things together. I will go into that in a minute, but it acts as an optimization fence. I'll explain that term in a second. But yeah, this is what materialization basically means. It's evaluated, stored as a temporary table. The primary statement will use it as many times as it needs to. Before version 12, CTEs were always materialized and never inlined. I will explain those two words now. So by always materialized, it means that the result was stored in a temporary table, and you would use it for the duration of the query, right? By inlining, I will go back to the word optimization fence now. By inlining, it means the planner cannot plan the two things thinking of them as one. What I mean by that is, if there is a CT part and there is a primary statement as well, if in that example, if we go back to the same example where I explained to you that you cannot push conditions down from, if there is a condition where clause anything, you cannot push that down to a CTE. The planner cannot do that because the CTE is a black box. I cannot think of a way of planning the CTE and the primary statement together, that okay, maybe I can plan them together and it will be a better plan. So that the CTE part is a black box, you have to evaluate the results, stored as a timely table, use it as many times as you want. This is the thing before version 12. What happens in 12 and after 12 is there is conditional materialization, and we'll discuss these conditions now. There is conditional materialization, and the planner will consider inlining, right? I will explain those conditions now, but by inlining again, now I mean that it can think of these things as one, right? Okay, I can probably push the conditions down, I can probably plan these two things together. And by together, I don't mean that it's planning two different plans. What I mean to say is that it can evaluate the two things together, the CT and the primary statement. And what are these conditions? So this is a simple flowchart. I hope it's simple. Explaining the three conditions which, explaining the three conditions which are the primary conditions deciding if it will materialize or not. So the first condition is if you have just 1 second, sorry. The first condition is if you have explicitly mentioned the keyword materialize. Now, in version 12, you have from version 12 you have the possibility of explicitly writing the keyword materialize, and that's what the customer did, as I showed you in the beginning. So they added the keyword materialize because they could. So they're like, okay, let's try it. So they added the keyword materialize. So you can add the keyword materialize explicitly, in which case the planner knows, okay, I need to materialize this, right? Not in all cases though. There are some edge cases, but this is a simple flowchart explaining the most of the cases, but there could be edge cases not following this. If the CT is recursive, meaning if I need to use the result again and again and again, it's better to materialize it. So in that case as well, you will materialize if you see that there are multiple references, right? In the third case, if a CT has side effects, if it uses some volatile functions, in that case as well, it will materialize and it will not inline, which means plan both things together. I think inlining will be more clear in the next slides, but yeah. So these are the three basic conditions which which should fit in most of the cases. Now we'll try to go into them one by one and understand these three, right? This is a table which I've created, and we use the first case now, explicitly saying materialize, right? And it's a big table which has 1 million rows. And what I did was, the CT is very simple. It's just selecting from the table, everything. And then I have a clause. Then I have a primary statement which says select star from the table where the CT, the name of the CT, where S equal to 10, which is one specific row, okay? Now, the thing is, because it is materialized, right, the CTE will be first. The CTE part will be evaluated first. So this is the first step, right? That I am scanning the table, the complete table. And then I remove the rows by filter, because then I execute the statement S equal to 10. So this is general behavior if you explicitly mention materialize and if you are running on any version before 12. Okay, this is general. Now, what happens if I actually remove the keyword materialize, right? And or I'm on version 2. Yeah, I remove the keyword materialize. Then what happens? Then I see an index scan. And why? Because now the planner knows that it can inline the query as well, right? Because all the conditions, there is no materialize explicitly there. There are no multiple references or recursion. And there is no volatile functions present. So I can inline. I don't have to materialize. So in this case, it did inline the query. It did plan the two things together because it knew that it could pass that condition down to the CTE level. So it actually did that. It just did an index scan. And why was this example important? Because you need to know your indexes and you need to know what changes you're making. If you are writing materialize in front of that, you need to know what impact will it have on your existing indexes, right? So this is that. And yeah, this is just a comparison that, okay, with materialized it was doing that, what I explained to you, and without it will do this. Multiple computation, multiple references. This is another example. So this is a CT, PGCT, PGCCT, and I have multiple references of it, right? And that's why if you see, I have the CTE computed first, and then it will be used in the main one, right? So it is materialized in case of multiple references or even recursion. But we can use not materialized. So what I did in the same CTE which I just showed you, I just explicitly mentioned the keyword not materialized. And again, I see an index scan. So what does this actually mean? That when we materialize, we can't use indexes, right? Because we've already materialized it. So that, and this is an important part to note. Inlining is what I discussed earlier as well, but this is a better example explaining that. So basically, what I explained earlier was that that's version 11, and the CTE part, so this is an example showing that I'm selecting some columns from the employees table, and in the CTE part, I'm doing a select star on manager ID equal to 4 on a specific ID. Again, the same, similar to what I did earlier, right? The difference is, in version 11, because it has to compute the CTE part before, it will do the hash aggregate. It is doing a hash aggregate which is returning 7 rows, but after sequentially scanning the whole row, grouping, counting, then hash aggregate. I just needed 1 row. Here, if you see, I have simply pushed the condition down. I have done a sort, I have pushed the condition down, manager ID equal to 4, because I could inline. I had the possibility, because I'm on version 12, to let the planner decide if it can inline and if it was able to. Because the 3 conditions are again false. It is, I don't explicitly have the keyword materialize. It's not a CTE with volatile functions, right? And there is no multiple references, and also there is no recursion. So because everything is false, I was able to do, the planner was able to do that, right? And obviously, as you can see, the execution time is very different, right? In version 11 and 12. If you actually add the materialize keyword here, in version 12, it will give you the same plan as above. So now, coming to usage, let me see how much time I have. Okay, we are good. Usage and impact of materialized CTEs. Oh my God, I don't like this clicker. Yeah, so it can avoid duplicate computation of an expensive with query, right? Because as I said, if you are materializing, you just, the result is already stored in a temporary table, you reuse it again, and good, because you don't have to compute it again and again, right? It acts as an optimization fence, right? Because as I said, the planner can't plan those 2 things together, because it basically has to evaluate the CTE before. So if the CTEs are materialized, it will be evaluated beforehand. Materialization itself can be a bit costly. And why? Because if you are materializing, I discussed this when I was discussing workmem as well, you only have limited memory there, right? So if it's a bigger table, if it doesn't fit there, or if the operation doesn't, if the workmem is not enough for the operation, it has to spill to disk. And reading in and out from the disk is obviously more expensive than the memory itself, right? So materialization itself can be a bit costly. Indexes cannot be efficiently used after materializing, and that's what we've seen in some of the examples as well. And I think if you have to take one takeaway from here, it should be that if you are doing something, if you are explicitly, either let the planner do its job, let it plan, unless you have like major performance issues or something, you should look into your indexes anyway. But if you are adding something, like if you're making changes like adding this materialized keyword and all of that, you need to know what's happening. You need to compare plans, you need to see. And that's exactly what happened with the customer as well. So after coming back to their question, after understanding how CTE works, how everything goes, I asked them for the plans without the keyword, and I could see that if they drop that keyword, the plans, it's actually faster. The execution is faster. And the problem was that their indexes were not being used because they explicitly mentioned the keyword materialize. And again, they didn't know. They were like, okay, we are upgrading a version. It's okay. Probably we can just try this keyword as well because it's new. So yeah. So that was the thing. But you have to be sure of that if you are making some changes, you have to be aware of the, otherwise we are there at AWS to help you. Yeah. So now I'll go into some sample uses of CTEs, right? This is one of them. This is in the AWS Postgres documentation, RDS Postgres documentation as well. It is related to auto vacuum. It will basically tell you, now that Robert has already talked about auto vacuum and vacuum a lot. Basically, this is a CTE. It looks bad, I know, but you can just copy it from the documentation like I did. And it basically tells you what are the eligible tables, top 10 tables, which auto vacuum will tackle, right? And it is useful for understanding that, okay, these are my tables which are being targeted again and again, and maybe I need to do some manual work on them, maybe, if I really need to, right? Another one is this one. This is, I prefer this more than the previous one because this is more important. Because as Robert said as well, it's okay if anything else happens, but you shouldn't be hitting transaction ID wraparound, right? So this is a very useful CTE, again from the PG Collector tool by AWS, which actually tells you how close are you to wraparound. So percentage towards wraparound and percentage towards an emergency auto vacuum. So if you are close to auto vacuum freeze max age, how close are you to that? How close are you to actually triggering a emergency auto vacuum, which by the way triggers even if auto vacuum is disabled. And the second one is percentage towards wraparound. This is also important because you don't want that to happen. This is another CTE, again taken from the PG Collector tool, which actually shows you information about indexes and their sizes and some other useful information, which can be good to understand, okay, what are the indexes I have, what are the sizes, are they even being used? Can I drop them? Because as you know, if you have indexes lying around for no reason, it can cause a lot of problems. It will take storage, that's another thing, but it will also, vacuum has to go to these indexes, this, that, a lot of considerations we can talk about later. So now that I've talked so much about CTEs and advantages and how is it actually executed in different versions of Postgres, should you be using them? So I want you to ask yourself some questions, right? Will a subquery be worse? So if I write a subquery, how is it executed? How is it planned? Is it different than the CTE? Am I getting better plans? So this is something you need to evaluate. Is it more effort changing my CTE subqueries to CTEs? That also is a consideration, and performance, right? Will using temp tables be better? So you can have temp tables, you can have indexes on temp tables. The only thing is temp tables will, you have to manage the temp tables, and the other thing is also the vacuum considerations. Because auto vacuum doesn't touch temp tables still. You have to run vacuum and analyze commands explicitly on temporary tables, right? So that can be, those can be some considerations, and creating heavy usage of temp tables actually can cause catalog bloat, right? Catalog table bloat. So that is another consideration you need to think about. Will materialize help or hurt? Well, we discussed that, okay, expensive computations, yeah, you can use it again and again, but it can act as an optimization fence. You have to know about your indexes as well. Will a view or materialized view be better? Well, the answer to this is you can create views and materialized views, but the thing is the maintenance. You have to maintain the permissions to the views, who can view what. You have to, if it's materialized views, you need to refresh them. So that is the maintenance overhead you have to think about, right? So all in all, it really depends, like all on, like other performance tuning decisions. It really depends if you should be if you should be using CTs or not. But you should ask yourself these questions and keep in mind the other things which we have. So I would like to end this talk with a quote from Dipes. He's a community member, and he found this change from 11 to 12, making everything materialize by default a bit abrupt. But he still says that improvement is being happening, and I'm happy about that, and I take that as a good feedback. So yeah, good work is happening, and we are improving Postgres. So thank you very much, and I thank you for your time, and I hope you enjoyed this. Thank you.
Any questions for Divya? All right, no questions.
Perfect.
That is a thorough talk. Thank you,
Yes.
Divya.
Yes, yes.